This is 7.3. There are 6 questions we need to do. They deal with quadrilaterals. So, we've done something like this before. A square. You want to select all properties that must be true. So in a square, are all sides congruent? Yes. Does a square have 2 pairs of parallel sides? Yes. Does a square have only 1 pair of parallel sides? No. It has 2, and using the word only turns it into a trapezoid. And does the square have 4 right angles? Yeah. All right, next one. So using those shapes, figure out which ones are parallelograms. Which of those 4 are parallelograms? Or sorry, which of those 3? All of them are parallelograms. Okay. Which ones are rectangles? The first 2, and so on. Okay. Given the information marked on the figures below, classify each quadrilateral as parallelogram or not necessarily a parallelogram. So in some cases they might be, but it's not a guarantee. All right, so look at that first shape. Does that shape have to be a parallelogram? Well, let's look at what they gave us. So we know this angle is equal to this angle, and that angle is equal to that angle. Does that have to be a parallelogram? Well, one of the questions you need to ask is, could I pull one of the vertices and create a different shape that is not a parallelogram? So if I grabbed onto this, could I move that without affecting you? Do you see what I mean? If I push R in, does that force you to come in? No, why not? There's no connection between these 2 angles and these angles, right? So if you pull on one side, you're not going to affect the other side. So that is not necessarily a parallelogram. It might be. Okay. Here, if I move A in, is that going to move D in? Yes. Because this angle is connected to that angle. So by pushing A in, that angle up on vertex B would have to change, which would pull D in. Does that make sense? Okay. Sure. Let's do some more. All right. If vertex V and Y have the same angle and vertex W and X have the same angle, does that have to be a parallelogram? So if I pulled on X, let's say I pulled X out, is that going to affect W? Yeah, X and W have to have the same angle. So if I stretch X out, then W has to stretch out as well. And that's true for all the sides. Okay? So yeah, that one has to be a parallelogram. Okay, the next one. So not only are these 2 sides parallel, but they're also equal lengths. What do you think? Does that guarantee a parallelogram? Well, does this side have to be parallel to that side? Yeah, because they're equal lengths. then the other two sides have to also be equal lengths, which is going to force them to be parallel. Okay, next up. All right. How do we know if something is a parallelogram if we have its points? How would you test to see if this is a parallelogram? Well, there are two qualities. If these two sides, if these sides are the same length and these sides are the same length, then it has to be a parallelogram. But finding side lengths in the coordinate plane is kind of a pain. You have to draw a triangle and use the Pythagorean theorem, or you could use the distance formula. That's kind of a pain. But yeah, how else can I prove something's a parallelogram? If it has two sets of parallel sides. So all we need to do is find the slope. Slope is rise over run. So this one is 1, 2, 3, 4, 5, 6, 7, 8 over 3. 8 over 3. Then I count the other one. 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3. Is that enough? Nope, that proves that it has one set of parallel lines. I need to do the other ones. So this would be down 1, 2 over 1, 2, 3, 4, 5. So negative 2/5. And this one would be 1, 2, 1, 2, 3, 4, 5. Negative 2/5. Is that a parallelogram? Yes, we have two sets of parallel sides. Oh, I want you to find length. Okay. All right. So we do need to do the distance formula. The distance formula is the square root of x plus x over 2. No, sorry. It is x minus x squared plus y minus y squared. Now, the reason I messed up that formula is because I don't have it memorized. It's just the quadratic formula, or not the quadratic. It's the Pythagorean theorem. So I'm going to draw a triangle right here. The left side of the triangle is an 8, and the top of the triangle is a 2. So we get 8 squared plus 2 squared. That's 16 plus 4 is 20. So c squared equals 20. We take the square root. C is equal to the square root of 20. Okay. So down here, it wants to know QR. Oh, I did the wrong one. I'm sorry, guys. I am failing today. All right, it wants me to find QR and PS. So I draw a right triangle, 2 and 5. 2 squared plus 5 squared equals c squared. 2 squared is 4, 5 squared is 25. So c is equal to the square root of 29. Then I do the same thing for PS. I draw a right triangle, 2 and 5. That is also going to give me the square root of 29. So down below, the length of QR is the square root of 29. Notice it says do not give decimal approximations. QR is root 29 and PS is also root 29. Okay. Now find the slope of QR and the slope of PS, which we already found was negative 2/5 in both cases. So what do we conclude? Well, we just learned in one of the last problems, if you have a four-sided shape and you have equality and parallel, that guarantees parallelogram. Okay, there are other ways to find parallelograms. Obviously, if you have two sets of parallel sides, it's a parallelogram. And if the top is equal to the bottom and the left is equal to the right, it's also a parallelogram. So any one of those three proves that it's a parallelogram. Okay. What do we conclude? The first one. The quadrilateral is a parallelogram because it has one pair of opposite sides that are both congruent and parallel. All right. Okay, we're going to try this. Hopefully it's not too bad. Here is a proof. Instead of you doing all of the proof, you just need to fill in the missing pieces. And if I end up not liking it, I'm going to throw it out. So, in this parallelogram, or in this shape, A, B, C, and D, we know that A is equal to C and that B is equal to D. So we want to prove that it's a parallelogram. Okay. So they have said both of the givens, and we know that A plus B plus C plus D is 360. How do we know that? That is the quadrilateral angle sum property. All quadrilaterals add to 360. Okay, so A plus B plus something equals, we want to use substitution. Okay, so if I say that A plus B plus C plus D is 360, and I know that this is true and this is true, then what can I substitute for angle C? Angle A. So I'd put an A right there. And then D would be angle B. What is that going to equal? Still equals 360. Okay. Oh, my heavens. All right, we're just not going to do this. Nope. Nope. I don't like it. I don't like it. Sorry. Not my best performance. Yeah, I'll cut that one out of your assignment. And nope, we won't do it. All right, you just have those four. Get to work.